Bismillahirrahmanirrahim. Welcome to the second part of the seventh lecture of Statistics and Probability Theory. We will continue with the topic random variable. As we have defined in the previous slides, the random variable is a real valued function defined on a sample space of a random experiment. We have two types of random variables: discrete random variable, continuous random variable. Like we know that variable is something which is not fixed. So a discrete random variable can assume a countable number of values. Like something which we can count is discrete, and if it is associated with a variable, so we can say it as a discrete random variable. For example, number of steps to the top of the Eiffel Tower. A continuous random variable can assume any value along a given interval of a number line. If we talk about the continuous random variable, it is something which we can measure it in a given interval. For example, the time a tourist stays at the top once he or she gets there. So continuous random variable is something which we can measure in a given interval, and discrete random variable which we can count. For example, number of sales, number of calls, shares of stock, people in line, mistakes per page, all these things can be count. These are countable things. Length, depth, volume, time, weight, all these things cannot countable. All these things can be measured in a given interval of time. If we say we have two types of random variables, continuous and discrete, so each random variable or each type of random variable will generate a probability distribution function. If it is discrete random variable, then we will have discrete probability distribution. We can also say it PMF. PMF refers to as probability mass function. And this is continuous random variable, and continuous random variable is also called probability density function, and we can denote it as PDF. Discrete probability distribution. The set of ordered pairs x f of x is a probability function or a probability mass function or probability distribution of discrete random variable x if for each possible outcome x. As we know, we are associating a random variable with a real valued function with a sample space of a random experiment. Whenever we substitute the value x of a random variable, we will get in the resultant value of the function, which is f of x. This f of x is basically the probability of that particular outcome. For example, if we toss a single coin, as we have discussed in previous slide, it would be x is equal to 0 or x is equal to 1. We are associating x is equal to 0 with head and x is equal to 1 with tail. So our random variable will have values x0 and x1. So what will be P of x? P of x means probability of that particular event. This is P of 0. Whenever we substitute this value 0, we will get some probability of occurrence of that particular event. If we substitute x is equal to 1, it means P of 1, we will get the probability of that particular event. As we know, x is equal to 0 means head, and we are tossing a single coin, so we know that its probability is 1 by 2. Number of favorable outcomes divided by total number of outcomes. And if x is equal to 1, we are going to find the probability of the event that the tail occur, and its probability we know that it is 1 by 2. So, if we sum this probability and we know this particular experiment or tossing of a single coin will have only two possible outcomes, head or tail. So sum of this probability P of x is equal to 1 by 2 plus 1 by 2 which is equal to 1. So total probability is, sum of probability is 1. These all things are written in these three points. F of x is basically this f of x is P of x. As this is real valued function, whenever we substitute a value in the function, P of x will come, that P of 0 means 1 by 2, P of 1 means 1 by 2. So whenever you input the value of x, you will get the resultant probability P of x. So this f of x is basically the P of x. So P of x or f of x should be greater than equal to 0. There should be some probability, and you know whenever f of x is equal to 0, it means it is an impossible event. Sum of f of x is equal to 1. It means sum of all probabilities of all the events should be 1, as we have seen here in this example. P of x is equal to x is equal to f of x, like I am writing here P of x, and here I have mentioned it f of x. So these two things are same. Example, a shipment of 8 similar microcomputers to a retail outlet contains 3 of that are defective. If a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defectives. As you can see, this is the case of discrete random variable. It, as there is mentioned, number of defectives, you can count the number of defectives. They are not measurable, they are countable. So if we gather the information written in the question, there are total 8 microcomputers, and let me denote D with defective and ND with non-defective. So we know that 3 of them are defective. So what about the remaining 5? It means the remaining 5 are non-defective, and school is purchasing a random purchase of 2 microcomputers from this. So we are interested in number of defectives. So our random variable is associated with number of defectives. So x is equal to number of defectives. X is equal to number of defectives. So how many values x can possess? X could be 0. It means when a school makes a random purchase, there would be no defective. X is equal to 1. It means if a school purchased two of these computers, one of them is defective. X is equal to 2. It means whenever this school makes a purchase of two computers, both of them are defective. There could be three values, 0, 1, 2. We have to stop here. That is, X cannot be equal to 3. Why? Because school is purchasing only two computers. So if they are purchasing two computers, so there would be maximum no defective means 0, or minimum no defective 0, or maximum two defectives means 2. X is equal to 2. We cannot go beyond these limits. Now we will make the probability distribution of this particular random variable number of defectives. So X can possess 0, 1 and 2, and P of X means whenever we substitute value X is equal to 0, we will get the particular probability. Now, how can we get this probability? Probability X is equal to 0, or you can write it as P of 0 like this. This means that the school have purchased two computers and none of them are defective. So by applying the probability definition of the probability of an event, it was number of favorable outcomes divided by total number of outcomes. Let me first find out the total number of outcomes. Number of favorable outcomes divided by total number of outcomes. As we know, there are total 8 computers and we have to select randomly only 2 computers. So possible outcomes would be 8C2, 8 combination 2. You have to select 2 computers from these 8 computers. So this is the way you can find out the total number of ways 2 computers can be selected from these 8 computers. Now we have to find out the favorable outcomes. It means that 0 are defective and we know that there are 3 defectives. So it means from these 3 defectives, 0 computers are coming. But we have to select 2 computers randomly. So it means both of them are coming from these 5 non-defectives. So this could be 5 C 2. So this is the way to find out the probability that X is equal to 0. It means that 0 defective computer is coming in the purchasing of 2 computers. Now how to sort out this? This is 8C2 means 8 combination 2. 8C2, you can solve it as 8 factorial. You can use your calculator too, but manually you can solve it as 8 factorial over 2 factorial and 5 minus 2 factorial. It would be equal to 8 factorial over 2 factorial and 3 factorial. So how we can open 8 factorial? It could be opened as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. As we have discussed all these things in previous lectures, I'm explaining it is here just for the recall. Divided by 2 into 1. You can open the 2 factorial like this way. I'm just putting the bracket here to separate the 2 factorial and 3 factorial, and this would be equal to 3 into 2 into 1. So this can be sorted out by 2, 2, 3, 2 is 6. Its answer would be, if you sort out this would be 28. By simplifying this, you will get 28. Now, so we got here that this is 28. Similarly, 3C0 is 1. You can sort out same in this way, into 5C2 is 10. So probability that 0 defective computers are coming in the purchasing of 2 computers is 10 divided by 28. This is 10 by 28. Now x is equal to 1. Probability x is equal to 1. It means you can write in this way too. P of 1. It means when the school will purchase 2 random microcomputers, one of them will be defective. As they are purchasing 2 computers, if one is defective, then the other one will be non-defective. So this one will be written as number of favorable outcomes divided by total number of outcomes. 3C1. We are using combination here because order does not matter here. So 3C1, but we have to purchase 2 computers, so other will come from here. Whole divided by 8C2. This is the favorable outcomes divided by total number of outcomes. This would be equal to, by simplifying this, we will get 15 by 28. Now x is equal to 2. It means the school purchased 2 computers and both of them are defective, which is equal to P of 2. So if both are defective, it means These are coming from the defective ones, 3C, 2, and what else? There should be 0 non-defective, 8C, 2. So this would be equal to 3C, 2 is 3. You can solve it manually or you can use your computer calculator. 3 into 1 divided by 28, which is 3 by 28. So this is 15 by 28 and this is 3 by 28. So if we want to know, this is complete probability distribution function, the sum of these probabilities should be equal to 1. Otherwise, this is incomplete. So if you sum all these probabilities, probability P of X, this is 10 plus 15, 25, 25 plus 3 is 28. So this would be equal to 28 by 28, which is equal to 1. So if you go back to these 3 points, f of x should be greater than or equal to 0. So we have some probabilities of the events, and sum of f of x or sum of p of x should be equal to 1. We got this one here. So it means that this is complete discrete probability distribution function.